Hello everyone, today we'll be learning in the clouds. Now let's get started. Today we will be learning about the solar system. The solar system consists of the sun, planets, and other objects within the sun's gravitational influence. Gravity is the force of attraction between masses. The Sun-Earth-Moon system provides an opportunity to study interactions between objects in the solar system that influence phenomena observed from Earth. Scientists use data from many sources to determine the scale and properties of objects in our solar system. Phases of the Moon. As the Moon orbits around Earth, different parts of it appear to be illuminated by the sun. The Moon does not produce any light of its own. It only reflects light from the sun. The Moon sometimes appears fully illuminated and sometimes appears completely dark. Although it changes in appearance, the Moon is always half illuminated by the sun. From our perspective on Earth, we see all, a portion, or none of the illuminated part of the Moon. These predictable patterns in the appearance of the Moon are referred to as a phrase of, the Moon. And here is a quick fact. In this section we're learning, it focuses on observable patterns created by the position of Earth, Moon, and Sun throughout the month. The Earth-Moon-Sun system also creates observable patterns through the year. It is important to analyze the system in order to describe how it creates repeating or cycle patterns. Lunar eclipses. Sometimes as a full moon moves through Earth's shadow. This is a lunar eclipse. During a total lunar eclipse, the moon travels completely in Earth's shadow. During a partial lunar eclipse, only a portion of the moon enters Earth's shadow. Since Earth's shadow is large and lunar eclipse lasts for hours, partial lunar eclipses occur at least twice a year. But total lunar eclipses are less common. The moon glows with a dull red coloring during a total lunar eclipse. This red coloring is due to the light from the sun being refracted through Earth's atmosphere. Seasons. Well, the Earth revolves in an orbit around the path a planet takes around an object. Initially believed to have a circular orbit, the Earth's orbit is actually slightly elliptical. As Earth moves throughout the year in new positions around the sun, the movement results in our 4 seasons: summer, autumn, winter, and spring. The distance from the sun doesn't have much effect on heating and cooling of Earth. In fact, the northern hemisphere is closest to the sun during the winter. So why don't we in the northern hemisphere feel coldest when we are closest to the sun? Well, Earth's axis of rotation, or imaginary poles on which Earth spins, is tilted at a 23.5 degree angle. And that's right, because of this tilt, one of the hemispheres is angled toward the sun. This causes that hemisphere to receive more direct energy from the sun. So as Earth revolves around the sun, the axis of rotation maintains its tilt. The axis always points in the same direction, which is toward the North Star, which is the Polaris, which is the combination of the Earth's revolution around the sun and Earth's 23.5 degree angle tilt are the reasons we have seasons. Now, we still have the northern hemisphere summer, which is the most important. Now, we do have the northern hemisphere winter, but the northern hemisphere summer is during summer in the northern hemisphere. The North Pole is tilted toward the sun. The sun's rays strike the northern hemisphere more directly. The region gets a lot of sunlight. At this time, the northern hemisphere experiences summer, while the southern hemisphere experiences winter. And that's how we have seasons. And that basically starts it off for our seasons that we have. Now, I know I said The northern hemisphere summer was really important, but we still gotta know about the winter. So here we go. Here's what's happening. During the winter in the northern hemisphere, light from the sun is spread out over a larger area. This indirect light is the same amount of light energy spread over a larger area on the Earth's surface. Therefore, the surface of the Earth does not get as warm. Well, additionally, with fewer daylight hours in the winter, there is less time for the sun to warm the Earth's surface, which is how winter starts. So during the winter in the northern hemisphere, it is summer in the southern hemisphere. In contrast, when it is winter in the southern hemisphere, it is summer in the northern hemisphere. So the hemisphere that is experiencing summer experiences more hours of daylight. So the hemisphere that is experiencing winter has less hours of daylight. And this is caused by the tilt of Earth. So summer occurs in the hemisphere that is tilted toward the sun. And this is when the sun appears high in the sky and its energy strikes Earth more directly and for longer periods of time. So the hemisphere that is tilted away from the sun experiences winter, and the sun appears lower in the sky. So overall, the Earth receives less direct energy from the sun for shorter periods of time. Now we have one last thing, then, well, you're done learning about these things. Okay. Get through this. This is the hardest one to remember. So, here we go. This is the orbital motion of the moon, which is here. Let me explain it, what I'm here to do. So, just as Earth orbits the sun, moons also orbit planets. The moon is affected by Earth's gravity more than it is by the sun's gravitational pull because the moon is much closer to Earth. The Earth's gravity pulls the moon toward Earth, and at the same time, the moon has forward movement of inertia that partly counters the force of Earth's gravity. This inertia causes the moon to orbit Earth instead of falling toward the surface of the planet. The next figure shows the forces involved in the moon's orbital motion around the Earth. And the diagram represents the forward movement or velocity of the moon and represents the gravity between the Earth and the moon. So the line encircling Earth shows the moon's actual orbit, which results from the combination of V and A. So V is on the left side of the Earth. And basically what it is doing, it is going down. And A is on the left side going towards Earth. So it is going across, like it's going to be like the equator and go straight through Earth. But V looks like it's trying to go out of whack. And that was the moon's orbit. So this is the hardest to learn, but it's just the orbital motion of the moon. So A and V are what you need to remember. The combination of V and A. V and A, V and A. Va. And that is the orbital motion of the moon.